Hello, in this short video we are going to investigate the following challenging problem on the topic of definite integrals. Consider the following equation, integral from 0 to x t squared over 1 plus t to the fourth dt equals to x minus 1. How many solutions does this equation have on the interval from 0 to 1? Pause the video at this point and give it a try to see which one of the following options is the correct answer to the problem. Okay, now let us solve the problem. My claim is that there is exactly one solution to this equation within this interval. To prove this, I proved two things. First, I proved the existence of at least one root or one solution of this equation within this interval. And then I will show that this equation cannot have more than one solution. So together, these two will imply that the equation has exactly one solution within the interval 0 and 1. For the first part, that I want to prove the existence of at least one solution to this equation within this interval, I want to use the intermediate value theorem. So let me remind you one narrative of that theorem which will be useful for solving this problem. So what is that? So let me put the microphone closer. Okay, so here I just remind you, let us say that I have a function f which is continuous on the closed interval a and b, and I know that if I calculate this f at this endpoint, I calculate f at the other endpoint and multiply them, it becomes a negative number. In other words, one of them is positive, the other one is negative. So intermediate value theorem implies that there exists a c within the open interval a and b so that f of c equals to 0. So in other words, if my goal is to know the number of solutions to this equation f of x equals to 0, and if I know f is continuous on this closed interval with this condition, the existence of at least one root of this equation is guaranteed within this interval. Okay, so this is the intermediate value theorem, one narrative of that which is useful here. And we also have the first part of the fundamental theorem of calculus. So if I have my function f, which is continuous within this interval, then this function integral from a to x is a number within this interval f of t dt. If f is continuous within that interval, this defines for me a function, so let me call it capital F of x. This function is also differentiable at every point within this interval, and we know that f prime of x, the derivative of this capital F of x, is just this simply f in which t is replaced with the upper limit x. Okay, so this also guarantees, because this capital F is differentiable, so it guarantees that capital F itself is continuous as well. Okay, so now by reminding these two, so let me start solving the problem. I define a function g of x in this form, integral from 0 to x t squared over 1 plus t to the power of 4 dt, and I move those parts to the left. Okay, so it becomes minus 2x plus 1. Okay, you have to be a little bit patient to see why this method works if you haven't already seen problems of this type. Okay, first of all, my claim is that this function is continuous everywhere. Why is that? Because minus 2x plus 1 is just a polynomial, and we know that every polynomial function is continuous everywhere. And why this part is continuous, exactly as I mentioned here, because this function is always continuous because the denominator cannot be 0. T to the power of 4 is non-negative. T to the 4 plus 1 cannot be 0. So this function is continuous everywhere. And now, according to this fundamental theorem of calculus, the whole function will be differentiable and consequently continuous. So I have a continuous function, I have another continuous function, I am adding them up, and then we have a theorem: if I have two continuous functions, the sum is also continuous. So this function g is continuous everywhere, including the closed interval 0 to 1, which is of our interest in this problem. But on the other hand, if I calculate g of 0, it becomes integral from 0 to 0, which is 0, and then minus 2 times 0, which is 0, and that is 1. And if I calculate g of 1, let us see what happens. This becomes integral. I have to replace x with 1 everywhere. So this becomes 0 to 1, t to the power of 2, 1 plus t to the power of 4, and dt. And if I put x to be 1 here, then minus 2 plus 1 is minus 1. So technically speaking, I should be able to continue and calculate this to see what g1 is. But calculating this integral is not easy. I don't even know this we can calculate. I have to think. But anyway, even if we can calculate, it might not be that easy to calculate. So I want to use some kind of estimate theorem for definite integrals to know if this number is positive or negative, because we already know g calculated at 0 is positive. If I am lucky and g of 1 is negative, then the product of g of 0 and g of 1 will be negative. Then I can use this narrative of the intermediate value theorem as I explained above. Okay, but how can I do that? So you see, this combination probably, if you have solved so many problems of this type, should be familiar to you. So it is not hard to prove that this combination is always less than 1/2. Why is that? So let us check that. Okay, so I can start from this always true inequality. So we know that 1 minus t squared is always non-negative because of this even power. And let me also start expanding that. So this 1 to the power of 2, 2 times the first one times the second one to power 2 is greater than or equal to 0. I move this term to the right. So this is equivalent to saying that 1 plus t to the fourth is greater than or equal to 2t squared. And then you can see that this is also equivalent. I divide everything by 1 plus t to the power of 4. So 1 is greater than or equal to 2 t squared divided by 1 plus t to the power of 4. And then I divide everything by 2. So 1/2 is greater than or equal to t squared divided by 1 plus t to the power of 4. Yes? Yes, that's correct, because 1/2 is greater than this, means this one is less than that one, so this is now correct. Okay? But why this is beneficial? Because now this is an integral whose integrand is always less than or equal to 1/2. So this means that this is less than or equal to the integral from 0 to 1, 1/2 dt minus 1. Yes? So this minus 1 is the same as minus 1 here, but we showed that this combination is always less than 1/2, and then we have a theorem that if within that interval my integrand is less than another integrand, the integral of the first one is also less than or equal to the second one. But this is extremely easy to calculate because 1/2 is a constant, so this becomes 1/2 t going from 0 to 1 minus 1. So this becomes 1/2 minus 1, which is minus 1/2. So now you see that if I define g in this form, g of 0 is 1, g of 1 is less than minus 1/2. So the conclusion is that whatever g of 0 is, g of 1 is negative. We don't know the exact value, but we know that this is at most minus 1/2, so this means it is negative. So anyway, I have g of 0 multiplied by g of 1 is less than 0. So this means that there exists a c within the open interval 0 and 1 such that g of c is 0. Okay? Well, what does it mean? G of c equals to 0, it means that integral from 0 to c of this minus 2c plus 1 is 0. And when I move this to the other side, it means that c is the solution of this equation g of x equals to 0. So existence of at least one solution is guaranteed in this way. But that is not enough to solve the problem, because we also have other options. We have options that there are one solution, two solutions, four solutions that we don't know. We have to guarantee that no, there is no more than one solution, of course, if we can. So let me clean the board and I will come back to you, okay? Okay, now this is the fundamental theorem of calculus. I rewrote it here again, and this was the function that I defined. Now I want to show that this function is strictly decreasing. So if the function is strictly decreasing, it means that if it is supposed to cut the x-axis, it will definitely cut the x-axis exactly at one point. It cannot cut the x-axis in more than one point, because if this is the x-axis and the graph of your function is supposed to cut the x-axis more than one point, the function, as you see, is not strictly decreasing. It is decreasing at some point, but it has to be increasing on some other numbers, on some other intervals, so that it will be able to cut the x-axis in more than one point. Okay, so if I can show that this function is strictly decreasing or strictly increasing, then I am done, because then I know that my function can have at most one solution. On the other hand, we already showed that it has at least one solution. So combining these together, it means that my equation will have exactly one solution. So how can I prove the function is decreasing or increasing? One possible way is to use derivative. If the derivative of the function is negative, the function is decreasing, and if the derivative is positive, the function is increasing. So it motivates me to differentiate my function. But if I want to differentiate this function, I can use this theorem. I just need to replace t with x, so it becomes x squared 1 plus x to the power of 4, and the derivative of minus 2x is minus 2, derivative of 1 is 0. So I now show that this number is a negative, yes? And this is exactly what we showed in the previous problem. Do you remember? We showed that t squared over 1 plus t to the power of 4 is always less than 1/2. Yes? Of course, if this is true for t, this is also true for x, because that is just the name of my variable. And if this expression is maximally 1/2, definitely when I subtract 2 from it, it becomes negative, strictly negative. So this means that the function g is strictly decreasing. So this means that if it is supposed to cut the x-axis, it will cut it exactly at one point, not more. It will not be able to cut it more than one point. On the other hand, based on the previous argument, it has to cut it at least in one point. So combining these two together, I was able to show for you, hopefully you could understand me, that this equation has exactly one solution within the open interval from 0 to 1. So this means that option B is the correct answer to the problem. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.